Yo, 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 yo. Hello, everybody. Yo. Yo. All right. Yo, yo. Yo, 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 yo. All right. Sorry. Yo. All right. Last video of the year. Had to get all my yos out. Okay. So we're going to talk about systems of linear and quadratic equations. So we're doing systems like we've done before. We've only done systems of linear equations. Now we're doing systems of a linear and a quadratic equation. So let's just get after it. So here are the possibilities with linear systems. A system of linear and quadratics. Is if we were to look at a graph, because when we first learned how to graph linear systems, is we graphed two lines, and wherever those lines cross, that was our solution. Well, now we're doing the same thing, but now I'm graphing a parabola, and I'm graphing a straight line, and wherever they cross, that's the solution. So like in particular this graph right here, here's a system where I have a point right here, here's my parabola, here's the straight line, so it has one solution. If it was this green parabola though, they never cross each other, so therefore there's no solution. And if it was the red parabola, they cross twice, so there's two solutions. So just like all quadratic equations, there's a possibility of no solution, one solution, or two solutions. And this would be another example as well. So for graphing, we're going to learn three ways, just like when we learn regular systems. We're going to learn how to solve these by graphing, substitution, and elimination. Okay, so first, if we look at how, if I were to look at a system of linear and quadratic equations, I can have it as two equations, or I might have it something that looks something like this. If I look at the left side, that's just x squared minus 5. That is a quadratic equation. And if I look at the right side, this is a linear equation. I can plot both of these on the same graph. Okay. Oh, I'm sorry, I had this backwards. This is positive 5, negative x squared. Whoops. Okay. That's better. So now, I can graph these on the same graph. So x plus 3, it's pretty simple to graph. 1, 2, 3. There's my y-intercept. Up 1, over 1, up 1, over 1, down 1, over 1. There we go. So there's that graph. Easy enough. So, made my graph. Now I also have to graph on the same coordinate plane. I'll do this one in purple. Negative x squared plus 5. Well, I know the vertex is at 0, 5. So there's my vertex. And the reason why I know that is there's no middle value, and this is the y-intercept. So if I did like the b, negative b over 2a, well, b is 0, so 0 over anything is a 0. So that's why I know my vertex is at 0, 5. So vertex is at 0, 5. Now I look at my slope, we're going down 1 over 1 for the first point. I already have one solution right here. And so I know this side, but I got to figure out when is it going to cross it again over here. So I'm going to figure out the next point over. I'm hoping it's at negative 2. So the next x value over is negative 2, so I'm going to plug that in here. So let's see here. If I have negative 2 squared plus 5, that's going to give me negative 4 plus 5, which is negative 1. Oh, look at that. I'm sorry, positive 1. And look at that. That worked out really nicely. Or that's the point. So I have my solution is at these 2 points. Okay. So the solution of the system is where the two graphs intersect. Okay. And it's the x values that I'm really looking at here. So my x values are going to be, let's see, this one's at negative 2. And then the x values are also going to be at positive 1. And that would be my solution to my system. Now what I could do is I could plug in negative 2 and see if it works. I could plug in positive 1 and see if it works. So if I plugged in negative 2 into the original system, it should work out. I get 1 on this side, and we already solved this one, and we know it gets 1. So it does check off. Both sides are equal to each other. Okay. So, whoops, I made that, sorry, this is not for you. That's funny. That's for something totally different. Let's just move that out of the way. And let me make this a little bit smaller so you can actually see the equation. Sorry, guys. There we go. That's a lot better. All right, so I want to solve that equation by graphing. So go ahead and graph them both, pause it, try it on your own, and let's see how it goes. So I'm going to graph this one in blue. I'm going to start at +1 here. I know it's up 1 over 1. And then let's see here. If I plug in 2 squared plus 1, that's 4 plus 1 is 5. So at 2, I'm at 5, which axis of symmetry means at -2, I'm also at 5. So that's what that graph looks like. There's my parabola. Okay, now what I want to do is I also want to graph my other line, x plus 3, starts at 3 here, up 1 over 1, there's one solution, there's the other solution right there. That's always nice when it works out so beautifully. As we know, that doesn't happen all the time. My x values and my solutions are -1 and +2. So x equals -1, x equals +2. All right. So now I'm going to show you how to solve a system of equations by using the substitution method. Or actually, let's look at, maybe we'll do elimination first. Let's look at this one with elimination, and then we'll do substitution afterwards. Yeah, that's the order I have planned. So we're going to do elimination first. So this is so if we don't want to graph, we don't have to. So when we solve systems of linear equations, if I had like y equals 2x minus 4, I'm making up these numbers real quick. And then I had y equals, I don't know, 3x plus 4. What we learned is that if I want to solve the system, I can combine these systems by adding them together, as long as something's going to cancel. Well, if I look here, -4 and +4 will cancel, so now when I add these, I get 2y equals 6x. But I wanted a, I'm sorry, apologies. I want a variable to cancel, right? I have to have a variable cancel. These canceling doesn't help me out, but I need a variable to cancel of some kind. I need my y or my x to cancel. So if I were to subtract these, y minus y is 0. 2x minus 3x is -1x, -4 minus +4 is -8, and then now I can solve this equation for x. That's how we solve systems of linear equations. I don't know why I was being a bonehead and trying to cancel out the 4. Sorry, guys. Or a bozo. Now, we're going to do the same thing over here. We're going to try to combine these equations so that one of the variables cancels out. But the obvious variable to cancel out 90% of the time is going to be the y value, because we have an x squared and we have an x for our quadratic, so it's going to be really hard. We can't make those cancel, but I can always make the y's cancel. So if I'm looking at this particular system, what I can do is I can subtract them. If I subtract them, though, I have to make sure I line up my values appropriately. So I'm going to rewrite this here. If I have y equals x squared minus 6x plus 8, and if I subtract y equals 2x minus 4, I'm going to move that over here. Now, there's two ways that we looked at this when we did linear equations. We can just subtract it, or we can multiply. Really what we're doing is we're multiplying everything by -1, and then we're adding them. So if I multiply everything by -1, I'm changing the sign of all of these. So instead of positive y, it becomes negative y. -2x, +4. Okay, so I'm subtracting all of this, so if I multiply everything by -1, now I'm just combining everything. Because now when I add these all up, those cancel, I'm left with 0 equals x squared, nothing to combine that with. -2x, -6x makes -8x, and I get +12. Now I have a quadratic equation that I can solve. So this is a quadratic equation. I've eliminated one of my variables, so I can just solve for x from here. What I'm going to do, though, is whenever we solve a quadratic equation, we always look at, hey, can I factor this first? If not, then I can look at completing the square or going into quadratic formula. But the biggest thing is I want to eliminate that y value by just subtracting or multiplying everything by -1 to eliminate the y. Now I can solve. This is factorable because, let's see here, 6 and 2. I knew it was factorable. It took me a second there. X minus 6, x minus 2 makes -8 and +12. So x equals 6 and x equals 2. So there's my solution to this particular system. Okay. Now, one thing I want to do to make sure that we didn't mess up here. Hold on real quick. I'm trying to get a tool here. This is not working. There we go. So what I need to do is I need to plug these values in though. I'm sorry, I almost missed a step here. So let me talk about the difference between the ones we did before and this one. This equation, there is no y, right? There's no y in this equation right here. So I'm only looking for the values of x that are going to make this true. I'm only looking for the values of x. There is no y in this particular equation, so I only want the x values. But in this system, I do have a y. So I do need to figure out my y values that go with each x. So I found my two x values, 6 and 2. So what I need to do is I can plug them into either one of these equations to figure out what my corresponding y values are. So then I'm going to have my 2 points that are solutions. So if I take, I'm going to use the linear equation because it's a lot easier to work with than the quadratic. So if I take y equals 2x minus 4 and I plug in x equals 2, then I get 4 minus 4, and I get 0. So that means for this particular equation, the final solution is 2, 0. I also have to do the same thing, but I need to do it with x equals 6. So that's 12 minus 4, which is 8. So that's going to give me the point of 6, 8. The reason why it's 6, 8 is because when x was 6, y was 8. When x was 2, y was 0. And that, because of my elimination method that I did in the beforehand, if I use the quadratic equation, I should get the same thing because those 2 points should be on that parabola. So when we have an x and a y, we have to make sure that we substitute in the x value, and we have to solve for the y values as well, so that we have our points. So here are my final 2 points, and that is the answer to this particular system. Okay, try this one on your own, elimination, solve it. I need 2 points. There is a y here, so I need to get an x and a y value. Okay, so I'm going to line these up. I personally, this is just the way I like to do it. I like to line up the quadratic on top, and then I'm going to do the linear on the bottom. I just set it up that way all the time. I don't know why. It's just, for me, it just works. I'm going to multiply all of this by -1, so that means I'm going to switch all of the signs here and make this one a -4. So what I did here is I multiplied all of this by -1 to get this. Now I can add these together. Y minus y is 0, x squared, and then I have positive x minus 6. So now I eliminated the y variable. Now I can solve my system here, my quadratic equation here, and I'm going to try to do it by factoring if I can, which I can because 3 and 2 makes 1, so that's going to work out really nicely. So I have x plus 3 and x minus 2 equals 0. So therefore x equals -3, x equals positive 2. Now I have to take those x values and plug them back in. I'm going to use this top equation here. So if I have y equals negative whatever x is, well if x is -3, I have positive 4. So that's 3 plus 4, which is 7. So that gives me the point of -3, positive 7. I also need to do that again for positive 2, so that's -2 plus 4, which is going to give me positive 2 because -2 plus 4 is 2. So that's 2 for my point. So my final solutions are -3, 7, and 2, 2. Okay, now we are going to learn our final method, which is using the substitution method. And now the substitution method, I think we could probably figure out what to do. This is when, if I have y equals something and I have y equals something, I can take whatever y equals and plug it in for y in my second equation. So I can rewrite this as 20x equals -2x squared plus 60x. And now this is the equation I'm solving. I could do it by graphing if I wanted to, but I don't really want to graph. So now I can try to solve this particular system, this particular equation. So what I'm going to do is I am going to subtract 20x from both sides to make it equal to 0. And now I get -2x squared plus 40x. There's a couple routes I could go here, but the route I want to go is I can factor this out because I have an x in both of them, and they're both divisible by 2. So I'm going to factor out a -2x. And that's going to give me x minus 20 equals 0, because now this is, I have the product of two different terms here. If this is equal to 0, this whole thing is equal to 0, and if this x is equal to, if this whole term is equal to 0, this whole thing is equal to 0. So I can solve my two different equations. I have negative 2x equals 0. I have x minus 20 equals 0. Well, divided by negative 2, x equals 0, add 20, x equals 20. So those are my two x values, 0 and 20. And now what I want to do is I want to plug those into my original linear equation. So y equals 20x. Well, if y equals 20 times 0, that gives me a y of 20. So this gives me, I'm sorry, y of 0. Man, I'm not thinking straight. Y equals 0. So this is going to give me the point of 0, 0. So there's one of my possible solutions. And then the other one, when x is 20, I'm going to plug that in. So that's 20 times 20. 20 times 20 is 400. So my other solution is when x is 20, y is 400. So those are my two solutions to this particular system of equations, of quadratic and linear equations. All right. Whew, that's it. It's a long one. Thanks for watching, you guys. And for things to remember, you know what? I want you to write your favorite thing about math class here. Okay? Favorite thing about math class. Right, what is your favorite part about math under your things to remember, or at least math in Mr. G's algebra class? All right, that's all I got. Do the independent practice, solve that system however you choose. Thanks for watching, guys. Peace out.